Here's an example of proof by induction. The formula for the sum of squares can be found in your information for candidates booklet, and it is that the sum of the squares from 1 to n is n over 6 into n plus 1 into 2n plus 1. The first stage of the proof is to check it works. Is it true for n equals 1? This is easy. The left hand side here will be just the list, in this case equal to 1. The right hand side will be the formula. That's 1 over 6 into n plus 1 into 2n plus 1. That's 1. It seems to work. Mathematically, that's all you'll need. Emotionally, you may need to try the first two terms. 1 plus 4 equals 5. The formula is now 2 over 6 times 3 times 5, and that again is 5. The process will work for the first term, first two terms. The next step is to test the formula for internal consistency. We assume that this formula now works because it seems to work for the first few terms. We know that the next term is going to be n plus 1 squared. If they add these, we should get this formula. What's happened here is I've taken the n and written n plus 1. n plus 1 is n plus 2, and two lots of n plus 1, that's 2n plus 2, plus another one is 2n plus 3. If we add these two terms, we should get that one. So let's see what happens. The first thing we've got is we have this problem with a number 6. We get around that quite easily by taking the second term and multiplying by 6 over 6. Now, when we look at this, that could be a cubic, and cubic algebra is quite hard. So what we do is we look for common factors. We have n plus 1 over 6. The remainder of the formula is now going to be n into 2n plus 1 plus 6 lots of n plus 1. You'll already notice that we quite like the first term. We've now got 2n squared and an n and another 6n and a 6, which is n plus 1 over 6 into 2n squared plus 7n plus 6. Now we know how this should factorise, and if we multiply these out, you can see the 2n squared, you can see the 3n and the 4n to give you the 7n, and you can see the 6 at the end. We've now completed our proof. From our first step, we know that the formula works when n equals 1 and n equals 2. We also have just proved that if it works when s is equal to n, it will also work when s is equal to n plus 1. And that completes the proof.